So it's important to understand that when you have an oceanic plate and a continental plate coming together, the oceanic plate is more dense, and so when they're merging together, they're converging together, the oceanic plate is the one that subducts, meaning goes below the continental plate. So this one's the oceanic plate, and this is the continental plate. All right? Now, they're moving towards each other, and what happens is, right here, the oceanic plate subducts below the continental plate as they converge into each other. So this right here is going to go down like this, right? And they're converging, so they're meeting together here. All right? And this right here, this is called a trench. That little space where they come together on the ocean floor is called a trench. Okay? It's the deepest part of the ocean. And as the oceanic plate subducts below the continental plate, and this is called the subduction zone, as it subducts here, it's going down into the mantle. And because it's going down into the mantle, it's getting very hot and it starts to melt. So this material starts to melt. That melted material called magma. So this is rising magma. Rises up into the continental plate and melts some of the continental plate, and then melted material rises, and that creates a chain of volcanoes. Okay? So the oceanic plate is subducting beneath the continental plate. The area where it subducts is called the subduction zone. The oceanic plate is melting in the mantle. The melted material, because it's more buoyant now, it rises up into the continental plate. It melts along with the continental plate and continues to rise, creating a chain of volcanoes. It's called a volcanic arc. Now, the oceanic converging boundary is very similar to oceanic to continental converging boundary. Okay? You have one plate moving one way. You have another plate moving towards the other plate. Okay? And they're both oceanic plates. Now, the question is, which one subducts? Okay? The one that's more dense is always going to subduct, just like in the lab you guys had with the wood block and the styrofoam block in the water. Okay? The one that's more dense will always subduct, but which one is going to be more dense? And the answer to that is the older one. The plate that's been around longer is going to be older, obviously, and because it's older, it's more dense. Now, the reason why it gets more dense is because over time, the rock that it's made of cools down. Remember, all the rock that the plate was made of was once magma. And over time, it gets cooler and cooler and cooler. And as it gets cooler, the more dense it becomes. Now, we talked about this in the last chapter. The cooler something gets, the more dense the molecules of the object become, causing the object to be more dense. Okay? Which means it's heavier for its size. And of course, if it's hotter, it's going to be less dense, because the molecules are more spread out, and so it would be less dense than the other one because it's hotter. So let's say this is the older oceanic plate. And this is the newer oceanic plate. When you draw these diagrams, it's important to label everything. Without labels, we have no idea what we're looking at when we look at your diagrams. All right, so we have the older oceanic plate and the newer oceanic plate. Remember, the older one is more dense, so this is going to be the one that goes below. It's going to be the one that subducts. Sub means below, so subduct means to go below. All right. And again, we have a trench here. All right, so we have the subduction zone right here. And of course, this is all taking place on top of the mantle. And the older oceanic plate subducting below the newer oceanic plate. And just like with the oceanic to continental convergent boundary, the subducting plate melts in the mantle. And the melted material is hotter and is more buoyant. So it rises up into the plate above it, melts along with the plate above it. The melted material, the magma, this rising magma, creates a chain of volcanoes. All right, now, they look like candles, but they're volcanoes. And this is a special type of volcanic arc because it's under the ocean, and when the volcanoes are tall enough, they become volcanic islands. And so, let me draw the ocean here, the sea level here. So this is what's called a volcanic island arc. Right. So with continental boundaries, you have a continental plate and a continental plate coming together. And they collide together. They keep moving towards each other, and neither one is able to subduct. Okay? They're too thick and they're too buoyant. They will not subduct into the mantle at all. And so what happens is it's like two trains coming together and colliding, or two semi-trucks coming together and colliding head on. And what we get is a big crumpling. Okay? The two plates, they crumple. All right? And we get mountains, like the Himalayan mountains. This is exactly how the Himalayan mountains is forming. And yes, it's still forming. So this is mountain range. And what happens, the two plates collide together, it crumples up, and it creates a mountain. And the top, it's all jagged, okay, until over time it weathers all the jagged points away. But because it's still forming, like the Himalayan mountains here, it's going to be jagged for a while. Some of these points are going to get weathered away, but it's still forming. It's going to continue to make these jagged points as it continues to grow. And the bottom is smooth and round because the mantle down here is magma, and it's melting all the edges here. So on the bottom, it forms a smooth, rounded shape, and there's more below the ground than there is above it, kind of like an iceberg. When we have an iceberg, here's the ocean, and then you see this iceberg, but this is all you see at top. Above the water, below the water, it's much bigger. Okay? Same thing with the mountain range. Here's the surface of the ground here that you're walking on, and there's the mountain. Above you, there's a whole lot less of it than there is below you. Okay? Because just like an iceberg, it's floating on top of the mantle, and the weight is causing it to sink down into the mantle. Okay? So it's much bigger than it appears, because when we're standing on the ground, we're still above all the bottom part of the mountain that's dipping into the mantle. All right, so that is continental convergent boundaries. We have finished our convergent boundaries. One thing that's important to understand with convergent boundaries is that all convergent boundaries create earthquakes.